This is a first test of a selective amplifier using a field effect transistor. This is the schematic diagram. So the field effect transistor is an emitter follower. I inject signal through a very small capacitor. There are inductors in the source and in the emitter of the following. Bipolar emitter follower, and I'm looking at the performance of this thing in a very ugly hookup, as you can see here. Well, what you see here is some other experiments. The crystal, actually two of them in parallel, has a very high impedance on the parallel resonance that comes with this capacitor. And there is also a series resonance a little bit lower in frequency. And we can see that on the noise floor, that on this side the noise is much stronger. Here is the series resonance. And I'm looking for the noise floor at the frequency of the series resonance. I can bring down the noise far away by putting more crystals in parallel to get a bigger capacitance. That will not increase the load on the crystals because that is determined by the voltage. So the noise I see is 2.0 dB, and I will connect the noise source to evaluate. No, I can't do that because it is below 3 dB. So I have compute what the noise floor is using the information that the noise figure of the system is 5.5 dB. I am now feeding 10 MHz into this amplifier, and I have set the level for the current through one of the crystals to be 17 milliamps peak to peak, because that's the level that I established as maximum to keep the Q of the crystal. Look at the previous nerds number 10. The output power I see now is 19 dBm plus 19. So this looks really interesting. I will try to do something like this more properly to see if this result holds.